Hey everyone, Mr. Allen here. I've been asked to go over some of these questions from the combination section. I'm just going to try to focus on them, try to focus on going through them fairly quickly. Full solutions are posted, but hopefully if we can visualize it a little bit, it might make a bit more sense to us. So the general idea of the question here is we have 33 people from whom to choose. We're going to choose 12 people to form a committee, and there are some restrictions in each case as to who those people will be. So the first one here, Jessica and Ryan cannot work together. So here are Jessica, here and Ryan, and here are the remaining members of the group, again, from whom to choose. There's a couple of ways to do these questions, or there often it will be a couple of different ways to do these questions. And the basic idea is if we can think about all the different possible groupings, we can then maybe focus on which ones are of interest to us. So in this case, if I am dealing with Jessica and Ryan as being kind of special cases, I could have a group that has just Jessica, not Ryan, and 11 of these other people. Any 11 is fine. I could have a group with Ryan, any of these 11 people, and not Jessica. And if it weren't for the restrictions, I could also have a group of these two specifically and any 10 other people. And of course, I could have a group of neither of these people and any 12 of these. So there's sort of four possible groupings here, one of which I don't want, three of which are fine. And so I can either handle the question, I can handle the question in either of those ways. I could basically go and say, well, I could have a group with just Jessica and sort of take Ryan out of the picture. And if I have a group with just Jessica, that means I need 11 more people out of these 31 to fill up her group. And there would be 31 choose 11 ways to pick 11 people out of this group to join Jessica. So that would be one possible grouping that is good in this case, because I don't want Jessica and Ryan both. I could do the opposite, of course. I could have Ryan take Jessica out of the picture and say, well, as long as we don't include her, we're still going to have a group that works, and then we would need another 31 people. We would need another 11 people out of those 31. And then the last possibility that would give me something that is valid, just take both of them out of the picture, and out of these remaining 30 people, out of these remaining 31 people, did I mess these numbers up? Call in the bin. 31, 11, the final group then is both Jessica and Ryan have been removed as possibilities, and we have 31 people from whom now we have to choose 12. And so this is one possible solution. Basically work those out. I don't need the J and R obviously, but just saying in Jessica's group we would have this many possible groupings that would include Jessica. We'd have this many possible groupings that would include Ryan, and this many possible groupings that would include neither one of them. So that's our first choice. That works nicely because there were only three possible groupings. If there were more possible groupings, if I had another person that I didn't want to have working with them and so on, and I'd have to have a group with just these two and just those two and not this one, sometimes it's easier just to look at the total group. So overall there are 33 choose 12 possibilities. So with no restrictions at all, I can pick any 12 of these 33 people. And if we just from that take away the number of groups that include both of these two. So if you think about the fact that the four possibilities I looked at were Jessica but no Ryan, Ryan but no Jessica, both Jessica and Ryan, and neither. The only one that's a problem is both Jessica and Ryan. So if we put both Jessica and Ryan into our group automatically, again there are 31 remaining people, and I would have 10 different people to choose. I'd have to choose 10 different people out of that group of 31 to fill up their committee. So this is the total number of committees without restriction. I take away the number of groups that have both Jessica and Ryan, and I will get the same answer as the previous example, or the previous solution, I should say. Okay, so that's sort of our thinking in these questions. I won't go through all four of these. I will look at the next one because I've kind of indicated the programmers here. I have 1, 2, 3, 4, 5, 6, 7 programmers, and the question said that there were 7 programmers. I want to guarantee myself that at least one programmer is chosen. Now what that means is I could have one programmer specifically, I could have 2 programmers, I could have 3, 4, 5, 6, or 7. And so in the same way that we sort of thought, well, there are 4 possibilities here, just Jessica, no Ryan, Ryan with no Jessica, both of them, neither of them. I now have, I guess I have 8 different possible groupings here. I could have a group with 0 programmers, with 1 programmer, with 2 programmers, all the way up to 7. So I don't really want to work that out as all those possibilities. What I will do though is what we sort of said as our second solution to the Jessica Ryan thing. At least one programmer, again, means 1, 2, 3, 4, anything up to 7. So the only one of our possible groupings that is not in this is 0 programmers. So 0 programmers is bad. It's the one thing we don't want. Now again, same argument. If we think about the fact that there are 33 choose 12 possible groupings, so that's total groups, with no restrictions. This is the answer to A, I believe, from the original question. And I simply take away the number of groups that have exactly 0 programmers, then what I'll be left with is all the groups that don't have 0 programmers, so have 1 or 2 or 3 or 4 up to 7 programmers. So if I'm thinking about 0 programmers, what I want to do is I can sort of think of it this way. There are the 7 programmers. Let's make them their own little group and choose 0 of them. And that leaves me out of the 33 total people, 26 to choose from. And I want to choose 12 out of that group of 26. And so total number of groups without restriction is here. I'm going to subtract just the groups that have no programmers because those are the groups that I don't want. And whatever I'm left with then will be the groups that I do want. The other 2 are similar here. At least 2 robotics members are chosen. We can do the exact same argument. Total groups minus, we want to take away the groups that have 0 robotics members. I guess I could do that fairly quickly. So again, same argument now. I believe there were 15 robotics members. So we want to take away the number of groups that have 0 robotics members, which would be, if there are 15 robotics members, I'm left with 18 non-robotics members. And so this is choose none of the robotics people and choose 12 out of the 18 remaining people. That's one of the groups, again, that I don't want. I want at least 2, so I don't want 0 and I don't want 1. And then same sort of thing here. If I look at the groups that have exactly 1 robotics member, it would be 15 choose 1 times 18 choose 11. So I pick 1 of the robotics members and 11 non-robotics members. That again is another group that I don't want. So I'm taking those away from my overall group. The last one basically says there must be between 2 and 4. So do the same sort of calculation, but in this case, what I do want is the groups that have 2, the groups that have 3, robotics members, and the groups that have 4 robotics members. So these are the groups I want to keep. And then out of the 18 remaining people in this grouping, I need 10. Out of the 18 remaining people here, I need 9. And out of the 18 remaining people here, I need 8. So from the 15 robotics members, choose 2, then choose 10 more people from the other group to fill up one of my possible legitimate groupings. I want between 2 and 4 robotics members. I want that. I want the possibility also of choosing 3 of them and 9 from the other group. I want the possibility of choosing 4 of them and 8 from the other group. Okay, I was also asked about this one. Basically, the idea is you have to write you have to answer 9 questions on a test. And the breakdown is as shown. There are 3 written questions, 8 short answer questions, and 4 essay questions, and you have to pick 9 of those to answer. In this case, there's a restriction again. You must answer at least 1 essay question. So if we picture this, I'm picking one of these, that one, and then I'm choosing 9 from sort of the remaining list. So that means, of course, I could end up picking more essay questions, or I could end up avoiding them entirely. So much like the last section now, I want to include the possibility where I've chosen 1 essay question, 2 essay questions, 3 or 4. So once again, a little bit easier is that sort of when dealing with the essay question specifically, there are only 5 possibilities. One possibility is that I don't pick any essay questions. One is that I pick 1 or 2 or 3 or 4. So so those are your 5 possibilities. Again, the only bad solution, or the only solution that does not meet this requirement, is when I pick 0 essay questions. So my best option is probably to deal with that, figure out how many ways I could pick 0 essay questions and remove those as possibilities from my overall grouping. So overall I have 1, 2, 3, 7, 15, I would say. So my total group, if I look at it, there are 15 questions on the test. I have to choose 9 of them. So without restriction, 15 choose 9, and again this will be the answer to probably question A from the original question here. 15 choose 9 is the total number of ways I could choose 9 questions on this test. What I want to eliminate are the times when I chose exactly 0 essay questions. So if I had 4 essay questions from which to choose 0, that would leave me with 11 other questions from which I would have chosen all 9. And so again, this is the bad case. This is I chose 0 essay questions. 0 essays, which is obviously the situation that I don't want here. If I look at how many ways I could do something that I don't want, and then take that away from the total ways that I could do anything, I'm left with the situation where I get just the ones that I do want. Okay, so that might have been a little confusing to say, but again, 1 essay question is good, 2 essay questions is good, so is 3, so is 4. 0 essay questions is bad. And so this is the number of ways I could choose 0 essay questions. I don't want to do that, and so I can sort of work that out. And this one I actually have sort of beside me, so I know that the first one is 5005. We're subtracting the 55 ways that I could avoid picking any essay questions, and what I'm left with is 4950 then. You must answer at least 2 short answer questions. So again, if I look at the possibilities with short answer questions, I now have quite a few. I could theoretically answer 0. No, actually I couldn't answer 0 because I wouldn't have enough other questions, would I? So I could answer sort of 7 of these and 2 of those. Oh, interesting. Sorry, I didn't remember this. But if we think about this one now, this is an interesting one for sure. Because I must answer at least 2 short answer questions, and I answered 9 total, my possibilities are in the worst case, or in the fewest short case scenarios, I could choose all 3 of these and all 4 of those, and then 2 of those. But that still meets the requirement here. You must answer at least 2 short answer questions. So there's actually no way for me to avoid answering at least 2 short answer questions. I can't answer 0 because if I tried to, if I said, let's choose 0 of the 8 short answer questions and choose, essentially we'd be saying then choose 9 of the 7 remaining questions. Well, obviously we can't do that. We can't also do 8 choose 1 and then choose 8 other of the 7 remaining questions. So it turns out that there is no way to avoid answering at least 2 short answer questions, and so my answer is going to be exactly this because there's no way to avoid meeting this requirement. So all of the possible solutions meet this requirement, so it's actually going to be just the same answer as in part A.